Hi, my name is Stephen Hill, and this is my final project presentation for GIS 512, Introduction to Environmental Remote Sensing. The title of my project is Using VIIRS Day-Night Band to Map Urban Extent in North Carolina. I was interested in using anthropogenic light sources collected from the Visible Infrared Imaging Radiometer Suite, or VIIRS for short, to delineate the urban areas of North Carolina. Nighttime lights have been used before to monitor urban development, but the capabilities of the recently launched VIIRS sensor have yet to be fully explored. The inspiration for this project came from earlier research involving the use of the Defense Meteorological Satellite Program's operational line scan system by people like Christopher Small and Chris Elvidge and others. Most researchers have found that there is a need to determine an appropriate threshold of light values to account for a blooming over effect of light extending far beyond the boundaries of urban areas. I therefore wanted to focus this project on finding a similar threshold for this dataset. This is the imagery tile that I downloaded from the Earth Observation Group at NOAA's National Geophysical Data Center. I wanted to use the 2 months composite imagery because it represents relatively stable sources of light. In other words, it minimizes the more temporal phenomena like gas flares and fires. The dataset is a composite of observations collected in April 2012 and October 2012 on nights with zero moonlight. The VIIRS sensor is aboard the SWAMI National Polar Orbiting Partnership platform, which passes over scenes at 1:30 a.m. Here's a brief description of the data. Notice the resolution is 750 meters by 750 meters. The other primary dataset I used for this project was the NLCD 2011 database created by the Multi-Resolution Land Characteristics Consortium. I needed a reference image of urban development in North Carolina with which to calibrate the light threshold of the VIIRS image, and the NLCD is the best of its kind. Classes 21 through 24 were used in my study to represent developed land. The two datasets were collected at roughly the same time period, so I felt that comparing the two images would have little temporal bias. In order to carry out this analysis, I used geoprocessing tools found in ArcMap 10.1 and VIIRS Imagine 2014 software. The first step was to rescale the day-night band image in VIIRS Imagine from 32-bit floating point to 8-bit unsigned. This converted the measured radiance values to a 0 to 255 digital number scale. Next, I opened the NLCD dataset and this rescaled day-night band image in ArcMap and extracted a subset of the data to the North Carolina boundary by using a vector boundary layer. In ArcMap, I adjusted the breakpoint for the night light categorization until it closely matched the underlying extent of the developed land cover. Finally, in ArcMap 10, I reclassified the data according to the threshold to give an approximate developed land cover layer. Here is a generalized geoprocessing workflow for my project. Here is a screen capture of the process I used to determine the threshold needed to estimate urban boundaries from nighttime lights. You can see the land cover thematic layer of the triangle overlaid with the day-night band imagery. In finding an appropriate threshold, it was necessary to overestimate larger cities in order to not lose smaller towns from the image. While this comparison is not perfect, it represents a much closer approximation than a sensor with a 5-kilometer resolution. After classifying the cells of the day-night band image according to the 2.7% threshold, I calculated the area of the developed land and compared it to the area of developed land cover in the NLCD 2011 dataset. The nighttime light still appears to overestimate the amount of developed land in the state of North Carolina, even with the threshold applied. And here's the resultant map of my analysis of this project. In conclusion, it appears the VIIRS day-night band imagery can be used to estimate the boundary of an urban extent up to a point. As other researchers have noted, there is a trade-off between minimizing the bloom-over effect of larger urban areas and maintaining smaller cities in the imagery. The results of the project were expected, although further analysis would need to be done to determine how the results could be improved with regards to approaching a more accurate estimate. Developed land cover might not necessarily be correlated with nighttime lights, and the temporal nature of the VIIRS satellite might need to be considered in further study. Demographic data may be incorporated to sort out developed lands into categories before applying thresholds to larger or different geographic areas. A follow-up question, can the greater sensitivity be used to map different intensities of development? Thank you.